Okay. Exactly. We have everything based on lambda. Now we just need to put it in our elliptic equation. Sometimes our elliptic equation is first PSD constraint, sometimes it is second, and if the ellipse binds, we have if the ellipse binds, we have deterministic solution. But if we have the formula for the ellipse in the structural result, my question is that the elliptic equation sometimes can, well, one thing is that you can sum the two terms by removing sigma ai aj from it, right? You can have a positive, I think that's how we come with the elliptic equation, is that those inequalities are holding and maybe one of them is binding, and I can have a positive linear combination of them, convex combination of them that still holds. No. Let's take a look at the welfare code. Even for welfare, competitive and collaborative are different. So we need to separate based on theta. And let's look at ellipse equation. Where is it? This is the obedience. Let's make it a structural result instead. Here, lie inside the ellipse of this equation. Yeah, we can, oh, okay. We can have a linear combination of the two constraints that ends up removing sigma ai aj from the two inequalities. Here, right? These are our obedience constraints. I will multiply the n minus 1 f minus r. I will multiply the first one in 1 plus r, which is positive, and the second one in 1 plus r, second one in f minus r. Then I sum them. 1 plus r will end up 1 plus f for t sigma 1 plus f, and then we will have our elliptic equation. Makes sense. One of them is binding, so perfect. I'm okay with this. Just here, what is the elliptic equation you have here? I think I'm ready to code, actually. Yeah, let's go. Ready to code. Um, um, hmm, consumers. So eta is like, let's assume 1 for now. Lambda. So hyperbolic, our x, based on what we computed, is, yeah, I will use ChatGPT. Well, we first compute nu. Give me the Python code that computes nu based. Sounds beautiful. Dude. Nu is numerator. Make it a one line code. That's it. Don't fuck. So nu is lambda f minus r 2 minus eta over 2 plus eta 1 or 1 plus r. Bro, ChatGPT is amazing. lambda should turn to L. F minus R times L minus R 2 minus eta over 2 plus eta over 1 plus R. Perfect. If nu, let's add something. If nu is less than 0, print wrong nu print R plus R if and return. So nu should not be negative. Then x is this one. Give me one line code for sigma AI. Actually, this is really easy. Sigma A omega over S sigma omega squared is 1 plus L plus nu over 2n. I don't want to use ChatGPT for this one. Y equals 1 over 2n 1 plus, these are bullshit. 1 over 2n, not even 1 over 2n. 1 plus L plus nu over 2n times nu. And right, 1 plus L plus nu over 2n times nu. X, what is X? We have formula for X as well. And what is X? That's the variable that we cannot do the code. I mean, take the copy paste this part. This one. So I can take a photo of it and check. It code for sigma AI theta I sigma AI theta I equals, well, I will divide it by T sigma theta I squared. So Control C. Bro, ChatGPT. It's amazing, man. We are the luckiest generation of people. We had ChatGPT, we had calculator, we had computers. Oh my god. This life is so good. Alright, what's going on bitch here? So sigma theta I squared, I'm gonna delete it because it is x. And I wanna delete T, I think is here exactly. Now I can delete these parentheses as well. So tap. So I have lambda plus nu plus 1, lambda plus nu plus 1 r squared plus 2 lambda. Oh, by the way, actually I was thinking maybe if we have a super strong OpenAI thing, like all of these papers after 2024, for example, we can give them and say how much novelty they have. Well, the models they come up with is novelty. Also, data sets are novelty. But at least for theoretical papers, I don't know. But a lot of things can be simplified. Where is it? Lambda plus nu plus 1 r squared. Okay, lambda should turn to L. And r squared plus 2L plus 2 lambda f, which is 2LF, times f minus r exactly, plus 2 nu 1 plus r, 2 nu 1 plus r, perfect, over 2 lambda f minus r squared and plus 2 nu 1 plus r squared. That's it. And we return x and y. Now lambda was on another curve. What was the curve that lambda was on it? Ellipse. Where was lambda 0? Okay, okay, we have this ellipse. And we have x and y on this hyperbolic curve. We start from lambda 0. If it is inside the ellipse, we are good, internal solution. If you are outside, we need to find the lambda that jumps inside. We start from lambda, for example, equal 1. If it is outside, we double the lambda, check if it is inside or outside. Oh, okay, so lambda is actually the parameter that defines the curve. So we double the lambda. If we are inside, we stop. Now we have an interval. We do the bisection method to find the lambda that cuts the ellipse. All right. And what is this? Ellipse is 1 plus r squared, We can make it more beautiful, and I wanna do that. Let me see. Let me see how much it cost us. I think I'm not gonna do that. All right, and ellipse is the same. Then we are gonna compute xx, yy, dd, and eta. It depends on the value of eta now. Um, eta, and the game is always competitive. We are in core now, so instead of competitive, I rate core now. And R is also -1/2, 5, 2, 0 exactly for eta, different values of eta. Now, where is the problem? If eta is less than 2, second PSD binds. If eta is greater than the first PSD binds. So x and y will be the hyperbolic from A and R, right? A is 0, the start of the curve lambda. The intake of the hyperbolic is the lambda and R. And they are in this hyperbolic curve. And ellipse, we say, okay, if x of ellipse is greater than 0, it means we are outside the ellipse. We said it as 1, m is 1, right? B is m, B is the inside and negative. B is inside and negative. B should fall inside. For lambda equal B, we should fall inside it and be negative. The value of elliptic should be negative. So we compute x and y hyperbolic of B and yr. While it is positive, which means we are still outside the ellipse on the curve, we double the value of B, right? And try it. And then once there is a point that because it is 2 to the end, we fall into it sometimes, and it is not very sure, long time. So we fall into the ellipse, we set that B as the good B, and so after this while finishes, we have 0 outside and the B that is inside, then we go bisection. If ellipse of x and y and r, why does x, okay, r, you should take value of r exactly, is less than 0, what should we do? It means we are inside the ellipse. And we are gonna it means we are inside the ellipse. We are gonna change our middle point. So we will keep our A, but we change our B to A plus B over 2, right? Sorry. We are inside the ellipse. Okay, we compute the ellipse at the midpoint. If it is negative, we are inside, we keep the middle point and A. If it is positive, it is outside, we keep B and the middle point, okay. Negative B minus A less than epsilon. By the way, we wanna, on this curve of hyperbolic, we want distance to be greater than epsilon. K is epsilon. If K is less than 0, we wanna keep C and A exactly. If K is 0, break. If K is greater than 0, K greater than 0 means we want B and C. And NP append, Y, LP append, and C is the lambda exactly. NP append 0. Yeah, because it's not an interior point. Oh, you're saying for the competitive, that's the case here now. That maybe you're saying it's binding all the time. It's not the case anymore. So I need to change this. that part is the same. Sigma Ij. I mean, it is the same shit, but I don't know why am I computing it. Else, it means that we are interior point. Oh, okay. For A0, we are interior point. And xi minus ellipse this over this, delta will be this, and this, and this. The thing is that depends on eta, which delta it is. Exactly. Now we can go to the structural result and say round f round sigma Ij round f sigma round sigma Ij is r2 minus eta over 2 plus eta. So if eta is less than 2, it's negative. And we have this form of delta, epsilon I minus epsilon j, and which I'm using. Let's see if I am using which one of these equations. So we have delta squared is square root of 19. Okay, so we are negative. Eta is less than 2. We are negative. Eta less than 2. We are negative. We want 20. F minus r1 plus r epsilon over r squared. Well, this one delta is 0 for sure. But here, interior point, xi f minus r squared 1 plus r squared. This is if eta less than 2. If eta is less than 2, then we want this to happen. I mean, if eta is equal to 2, what should I do? It's up to us, kind of. Because we have freedom in choosing sigma Ij. And actually, I don't want to have sigma Aj computed here. If eta is greater than 2, what do I want to do is that eta greater than 2 means round f round sigma Ij is positive and 19 should hold, right? Exactly, positive 19 should hold. It has maximally collaborative, and we should go f epsilon over r squared. r squared over r squared, and why lambda is 0, by the way? Why should lambda be 0? Oh, if interior point, yeah, lambda is 0. Okay. And delta and mean A is this motherfucker. That's true. So R positive cannot be the case. Actually, I don't care about payment. I don't care about revenue. I care about NP append. This 1/2. And that's it actually. No positive R. And MI bullshit, bullshit, bullshit. These are bullshit. Okay, perfect. Just eta equals to 2. What should we do? I have some freedom on choice of sigma aj once eta is 2. Eta greater than do first best binds. First PSD binds. Let's say eta 2 also. I want to make sigma ai aj as big as possible so that first one binds. Let's go. That sounds good. And okay, NST. Okay, we need to change S and T are 1 actually. Corno S is 1, T is -1. Is it going to fuck us up? Let's see if it's going to fuck us up. S is 1, T is -1. It's not gonna be a problem. Theta is 1. Theta mean omega is 1. And where omega, where theta. Perfect. And what happens if nu is negative? How can we make sure nu is not negative? Anyways, let's give value to eta. So eta is 1. Yeah, let's play with eta 1. And we want to plot x. npxx, just xx. That sounds great. And maybe we want to plot it for different values of eta. Here, bullshit. Label R, Y label. Exactly, legend. Do not save it. Show this. So we can see that it reaches 1 actually. Alright, that's perfect. Oh, it doesn't. Oh, we want it for R negative. Log. But we don't need log here. What if I increase eta, right? Any error? No. Nu is legend. Oh, we don't want legend. Fuck that. Just let me plot nu. So it seems nu are all non-negative, but I love to return x and y and nu also. Okay, x and where are we using hyperbolic x and y? X and y and in UU. I can use V. Wherever I use hyperbolic. I have no, see, returning 3 variables. No. Perfect. Internal. Sorry, why did I do that? Let's set eta at 3. How can I do it for 2 but not? Okay, I'll do this. That's more fun. Control C. Control V. That's not important. Unpacking. Well, do we have a... Oh, wrong. Okay, for R, this nu is negative. So what should we do if nu is negative? And it is hyperbolic, it's not the electric gas. How much is nu? Uh, what if nu is negative? What should we do with that? So, okay, in previous cases, we knew that nu cannot be negative because lambda f minus r over 1 plus r, f minus r is positive, lambda is non-negative, minus r is positive over positive. Okay, so now we need to make sure nu is positive. This is the term. I think it gives us a lower bound on lambda. That's what it gives us. Copy. Perfect. And this should be non-negative. Therefore, this is our nu. It should be non-negative, right? What we want to do is 1 plus r is positive, so we can say this term, this should be positive, non-negative, and f minus r should be greater than this, and we know f minus r is positive, so lambda should be greater than or equal r 2 minus eta over 2 plus eta over f minus r. Also, we know lambda is non-negative, so the start for lambda should be greater than or equal max of these two terms. And 0. Perfect. So we don't need to get nu out of the system. Just we can compute it. Then ellipse is this. We don't want nu anymore. And then here that we are giving it to A. Okay, A should be maximum of np.max, max of two things. R over F minus R times 2 minus eta over 2 plus eta, right? This motherfucker, R over F minus R times 2 minus eta over 2 plus eta and 0. That's it. I can say minimum value for lambda. So I don't need V anymore. If ellipse of this motherfucker is greater than 0, means that A is outside. B wants to be inside, and then, which is good. If ellipse of this motherfucker is negative, it means you're inside interior point solution. Then let me remove this and remove this, and then the rest is the same. Hyperbolic. Perfect. Where is B? Why do you start from the beginning every time? Alright, in a sense, we are just confirming data for ChatGPT. From now on, every expert is a machine, is a labor force, is a worker who is just confirming if ChatGPT did their things wrong. And it is all federated, by the way. That's crazy. Fucking crazy. I love it. Mm-hmm. If nu is 0, it means where it happened. Okay. And nu being 0 means first of all, eta is greater than 2, so I know first PST is binding, but nu is also 0. Is it possible that nu is 0? Yeah, it is possible. So if nu is 0, we cannot go to the second stationarity, and it gives us lambda right away. Lambda should be -1, which is not allowed. In second stationarity constraint, we divide it by nu, which is not correct necessarily. What if nu is 0, which is possible? If nu is 0, it doesn't mean lambda is something. We have lambda. Lambda is positive. Lambda is positive. And we have positive lambda. So we know that the first one is binding, and by the way, eta is greater than 2. We already know first one is binding. Lambda should be positive, and lambda is always positive though. If nu is 0 anyways, we know what the value of lambda is. What it means is that we know lambda sigma ai omega what does that mean? We have the lambda. Nu is 0, lambda is this. 1 sigma I omega won't be 0. Then it means that we can increase L to infinity by choosing sigma AI omega as positive as possible. Oh shit. So it takes 3 is positive. Yeah, print R. If nu is 0, we need to divide. You are saying nu should not be 0? No, it can be. Let's talk about nu can be 0. Means first best is not binding necessarily. You know eta is greater than 2, so first best should bind. But both of them are 0. Give me a second. Actually, it's obvious that nu will be 0, right? Kind of obvious, right? I will tell you why. So sigma AIAJ. Sigma bra bra bra. Okay, why the fucking nu is 0? Because it's obvious. Because we set nu to be 0 for the A we chose. But we have to talk what will happen if nu is 0 actually. Because nu is not negative and it can be 0. Jeez, what am I doing? Alright. So, come here. So we chose lambda based on this, but this minimum value of lambda sets nu to be 0. And then we cannot divide by 0. Right? Where is the formula for nu? That's it. This value of lambda sets nu as 0. So either we wanna make it a bit bigger. However, what if nu is 0? Nu is 0. Nu is 0. What if? So that's the case. So we wanna start somewhere plus epsilon. Like we wanna add a plus e error term. What is the healthcare? Who are these people who are called? AMN healthcare. Hello?
Hello, I was trying to reach Dr. Onyemi.
Oh, her number has changed.
Oh, it changed. Oh, okay.
Yeah, no problem. No problem.
You have a great rest of your day.
Thank you. Dr. Onayemi. Dr. Onayemi, if you are watching our video, I got your number. Please tell everybody who has your number, who had your number, to get your new number. Okay, then what if v is 0? What if v turns out to be really 0, right? Because our equations let v be 0, but we were assuming we are assuming here on the second stationarity, we assume nu is not 0. So let's see what happens if nu is really 0. Nu is 0. The first two copy, paste, and it happens when eta is greater than 2. Nu is 0, then we know that this is gone, and we have lambda actually 0. Then yeah, we cannot set nu 0 and then do the derivation. We compute the derivative, then set the nu as 0. Then nu is 0. This second one will turn out to this one. Equals this. But this one cannot be 0. Why? Because lambda is non-negative. So it will be minus s lambda plus 1. and this term is positive, minus s term is also what is minus s term in Cornell competition? S is 1, so this term is negative. L rho sigma ai omega will be negative okay, what will be 1 plus lambda plus nu over 2 n nu if we have this? As lambda. 1 plus lambda plus nu. Lambda is this term. Minus r 2 minus eta over 2 plus eta plus f minus r lambda. Okay. What? No, sorry. Lambda is this term. And we are saying it is positive. Wait, is this lambda positive, by the way? The first one, yeah. It gives us lambda equal r 2 minus eta over 2 plus eta 1 over f minus r. If nu is 0, lambda will be r 2 minus eta over 2 plus eta over 1 f minus r. R is negative, 2 minus eta negative. This lambda is positive, which is positive. Alright. Which means the first incentive is binding. So we have first best bind. First one binding. We have an equation. If it is maximum at nu 0. The thing is that because nu equals 0 is not an interior point for the Lagrangian, we cannot do the derivative at nu 0. Yeah, so we cannot even take the derivative and set the nu to the 0. So okay, the whole bullshit sucks. And Should I just start from? Yeah, nu 0 is not an interior point. This hyperbolic curve will cut our ellipse somewhere. By the way, you can see that nu is an increasing function of lambda. Let's just say the division by 0 is just, well, I have to talk, but let's add an epsilon here. And see how it goes. So it's not binding. Fucking, let's set eta as, what is eta? Oh, fuck. 10. Fucking sigma ai theta I is not changing at all. Where is sigma ai theta I? It's a function of nu. Nu is a function of eta, and it should change. What do you mean? If I set it 100. Do you feel any change? What if I set it 10,000? I mean, I don't feel any change. All right, let's plot them against each other. Insert cell below. It's equal 1. XX1 equals XX. Insert cell below. Beta equals 2 x2 and then I wanna add bullshit that I said that we we first need to take the derivative and set the via nu as 0. Actually, it is the opposite, because nu is not an interior part. I think still the derivative is continuous anyways. Infinite sigma a omega. Alright, let's plot this one as well. Oh, okay, they are different. RGB. So when I'm increasing eta, it is actually x is going towards 1, but will it be 1? Let's try. 4 more 0. I want to know if it is so how can I plot only x that are 1? X3. How many are there? Like 7, 500. 0 over 10,000, 5,000. X3. Fucking 4,500 to that. Still above 1. There's some of them. Is this x always above 1? Sounds like it. Oh, we don't know that. Okay. Well, this way I'm assuming nu is positive. First one is binding. Second one is binding. I'll plot delta, by the way. Delta is always 0. Deterministic. nu is 0, second one is the first one is binding. We have the value of lambda. Positive gives us sigma I aj, and first one is binding. Lambda is positive. Nu is 0, right? And we have around, by increasing sigma ai omega, something just based on sigma ai theta I. Minus s, which is minus 1, lambda plus 1 is negative. We want smaller sigma I for any values, but no, it's not true. Only other way is just removing the element of nu. Put this one. Like here, when we said sigma ai omega, nu is this. Which can be 0. No problem with nu being 0, but sigma ai omega, we need to compute it solely based on these terms. And then, even then, lambda f minus r, it will be 0, so fuck that. Even then it will be division by 0, so fuck. I think it's right, it's correct. Like, that sign is minor, I think. L of nu equals 0 minus, actually what we want is that L of nu minus L of nu equals 0 over nu. Is it for positive nu? So L of nu is greater than L of nu equals 0. Is that true? It means that we are increasing L. But that's not easy to compute. Yeah, fuck that. Let's assume that's true. Okay, I want to plot this actually. Plot RDD, fuck DD. XX times XX greater than equal 1. Alright, that sounds good. All 0. Greater than 1. Same thing. Okay, let's text Evo. This sounds it doesn't become 1. However, it brings it down. Let's take a look and see if only a small problem can be that nu is 0 from our starting point. Alright, for nu equals 0 I need some counter strike. What did I do? So V0. Let's play counter first. 1 round and a half is enough. What if V0? By the way, we know V0, right? No, we don't know. I don't know, I emailed Thibaut, so...
Let's roll.
Jeez. Okay, actually, that's a good news. Wow. Why are you there? Wow, you can do something here. Oh shit. That's how we move the... That's how we make the thing move, I guess. Yeah. Oh shoot, I didn't know that. Well, why did we move it? That's stupid, don't do that. Well, actually, that's good for us. You going to your home? Damn. Jeez, I'm killing good. Dude, can you fuck off? Let's go. Why isn't this one? Let's go. Dude, come on. That's so stupid. Let's finish this fucking game. We cannot undo that shit? That's so stupid. That was a good discovery though. I wanna... What am I doing? Just so arrogant. Motherfucker. Enough of you. Oh my god, they got all the good guns. I am still on this shit. Ah! That was stupid. Either don't play or play good. That's okay. He's done knifing. Dude, can you fucking... What the fuck is the locker doing? Jesus. Jesus. Ah. Who are you shooting at? Okay, one more round. Dude, where is it? Ah. Dude. Jeez. Dude. Move, move. Get the fuck out of here. Dude, it was more. Jump, jump, jump. Dude, he killed both. What the fucking... I'm hating myself. Let my friend down. Dude, fucking even fucking... Where are you? Where are you? Dude, finally. Oh, finally. Dude, I killed him. Alright, please fucking die. Yeah. Fuck! Wow, what a powerful gun. Ooh! Dude, I was so lucky actually. Wait, what the fuck? That was so fun actually. They were all dead. you know, this is it. What are these clouds? What are these clouds? Alright, let's get out of this. Nothing from Thibaut yet. Yeah, what happens if L nu is 0? So lambda is positive. Since lambda is positive, it means first one needs to bind as well. It means we have a deterministic solution, right? Nu is 0. First one is round. What is the first one? Sigma A omega. Sigma A I H A. First one is sigma AIAJ. First one is sigma AIAJ, and nu can be any parameters, even 0. Second one is sigma AI omega. Again, nu can be any parameters including 0. We are not doing round nu, so nu can be even non-zero. Third term is round sigma AI theta I. Again, nu can be any number. Like having nu non-zero doesn't cause us any problem at the derivation stage. So the bullshit that I corrected myself, that correction was wrong. Here we can compute. Okay, now if you say, what if nu is 0? Nu is 0. We know second one is binding. Then we will have minus r 2 minus eta over 2 plus eta plus f minus r lambda equals 0, which the same lambda will be r2 minus eta 2 plus eta over f minus r, which is positive. If it is positive, means first one is binding to. We already know second one is binding, and actually we have an equation for third one too, for sigma I theta I, which gives us the value of sigma I theta I. 2 lambda f minus r over r squared sigma theta I squared. 2 lambda f minus r over r squared sigma theta I squared. F minus r sigma AI theta I. So both constraints are binding. We have something from that too, by the way. It means the solution is deterministic given omega and theta I. Minus ft sigma theta I squared equals t times lambda plus 1 So 2 lambda f 2 r 2 minus theta 2 plus theta over f minus r r squared sigma theta I squared 2 lambda f minus r ai theta I minus ft theta I squared t lambda r 2 minus eta 2 plus eta f minus r plus 1 gives us sigma a theta I. Does it say x is 1? If it says x is 1, it's amazing. So that's it. Alright. And we want sigma a theta I. We don't want anything else. Sigma ai theta I will be 2 r 2 minus eta actually r will go away 1 over r sigma theta I squared f minus r sigma ai theta I ft sigma theta I squared if sigma I theta I is t sigma theta I squared, then we have 2 minus eta 2 plus eta or r sigma theta I squared f minus r minus ft will be f minus r minus ft. Oh, sorry, t is out. F minus r minus f will be minus r t sigma theta I squared equals t r 2 minus eta 2 plus theta eta over f minus r plus 1. So r sigma theta I squared goes away. T and t goes away. Minus comes here. So we have minus 2 minus eta, 2 plus eta equals r 2 minus eta 2 plus eta f minus r plus 1. What will be the value of r? Minus 2 minus eta plus eta f minus r is r 2 minus eta 2 plus eta plus f minus r f minus r minus 1 minus 2, 2 minus eta, 2 plus eta, right? Minus 1 equals r. Fuck you, 2 plus eta, oh shit. F minus f 1 plus 2, 2 minus eta plus eta equals r 2 minus eta 2 plus eta minus 1 minus 2 2 minus eta 2 plus eta that minus 2 that term goes away minus f okay minus also goes away times 2 plus f 2 plus eta plus 4 minus 2 eta equals r 2 plus eta plus 2 minus eta 4 over 4 r equals f 6 minus eta over 4. So if eta is but greater than 6, we can have r negatives. This should be greater than minus 1/2, which we can. Six minus eta should be less than 0, greater than minus 2 over f. Eta should be greater than 6, less than 6 plus 2 over f. So eta should be greater than 6, less than, over f is n minus 6 plus 2n minus 1. We know that first and second one is binding. Now we can compute sigma ai omega as well. So what? We can compute sigma ai omega, but do we want to? So we know the ellipse equation is binding. So we just need a big N for v nu 0, alright? Let's go to the structural result part. 1 plus r 1 plus r t squared sigma theta I squared. X is 1. 1 minus x0 will be squared, will be r4. And we know what is the r, by the way. R is f6 minus eta over r4 over 4. So it gives us the y. So what? We don't care about that. The only thing is that nu is 0. from KKT we have a stationarity conditions which are holding. Oh, is it holding or not? Shit is holding, yeah. Lambda plus 1 is not. Minus S lambda plus 1 is not 0. That's the thing. Actually, we know that nu equals 0 is not. Actually, that's very simple, yeah. Perfect. Nu equals 0 is not. Sorry, I was just confused. Nu equals 0 is not a. Nu equals 0 from f rho sigma ai omega will be minus s lambda plus 1, and this term is not 0, so therefore nu equals 0 is not optimal, and we can start from greater values. Perfect. It seems that okay, we can still have some stuff. However, if I choose, okay, this is for now. No, we cannot. It seems that theta is not gonna be effective. Therefore, I don't even want to compute the. If you're not going to add the consumer micro foundation, we are not gonna do anything further. Yeah, let me write an email to my colleagues and tell them. I'm not gonna do the Bertrand case, to be honest. I mean, it doesn't make sense. Just I around it goes for example. Even if I wanna do it for the Bertrand. Q is BP minus 1, da 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 da. So WF, everything, we have everything based on P. And the action is P, by the way. Fuck it, let's do it for Bertrand too. Alright, done with this one. I think it's good. We can go focus on our other project now. Well, okay, yeah, we can complete the benchmark section, and that's it. benchmark or Bertrand? Well, I have my computations here for Cornell. Alright, I'm done with it today. That's something I'm sure. I want to do some of my ranking. Ranking is more interesting actually.